the last lesson, we spent quite a lot of time talking about what we call straight lines. And so here's an example of a straight line. What else did we do that you remember from the last lesson about straight lines? What else did we learn to do? You can put your hand up and I'll unmute you, or you can put it in the chat. Just want to do a little review of what we did last time. What are some of the things we remember from last time? Who can remember something from last time? Aha, Kuchotso. Let's unmute Kuchotso. See what Kuchotso has to say. What do you remember from last time?
What I remember from last time, we did the x-intercepts, the y-intercepts, and we learned how to plot graphs and the gradient.
Fantastic. Yes. In fact, we had to plot graphs. And when we plotted the graphs, we needed 2 points, which are the x and y-intercept. And we also learned a bit about the gradient. Can you remember how we found the x-intercept? What did we do to find the x-intercept? And what did we do to find the y-intercept?
We let y equals to 0.
Yeah, so for that one, it was y is equal to 0. And for the y-intercept, it was x equal
to 0. We let x equals to 0.
Fantastic. Thank you so much. And Tego Vatso also said we learned about finding intersection points. So we learned about if we have 2 lines, and normally when we draw lines, we often have them on the Cartesian plane. When we have 2 lines, we learned how to find this point over here called the intersection point using simultaneous equations. So that's another word, simultaneous equations. And there's 3 methods that you can use. We looked at sometimes when they both in standard form, when say, for example, if we had something like this, if they were both written in standard form, you can just equate the two. So you just say, you can just say that one's equal to that one. Or if they're not both in standard form, let's say the second one was in that form, then what we can do is we can sub the easy one into the harder one. And that was another method that we looked at. You don't need to know the whole thing right now. You can always go back to the last video, but I just wanted to quickly recap those things. All right, then today, we're going to talk about basic f of x notation to start with. So let me show you what f of x notation means. If I have a straight line that looks like that, sometimes in mathematics, we say instead of writing this function as y equals 2x plus 1, we write it as f of x equals 2x plus 1. And what that means is this function is given a name called f. It still does the same, and it's not wrong to write. Sometimes they even write it like this, but it makes labeling the graph a bit easier. And there's also a way we can use this notation that is very useful. So if I say to you, what is the f of 1? It means what is the value that the function f takes on when x is 1. So you just put a 1 where x is, and the f of 1 would just be equal to 3. So I want to know from you very quickly, what is the f of minus 1? I'll call that a. I want to know what the f of 2 is, and I also want to know what the f of 7 is using this notation, or using this function f I've just given you. And you can pop your hand up if you feel confident, or you can put your answers in the chat. Both are fine. What does it mean when I ask you for the f of minus 1? If we look at the function f is here and the method we used over here. So we put a 2 and then a minus 1 there, and then that becomes minus 2 plus 1, which is minus 1. Yeah. So for a, f of minus 1, or the value of the function f, when Okay, Tando for B says 5. We'll have to check that, Tando. So I put a 2 where X is, and I agree, I get 5 because I go 2 times 2. Now, what's the F of 7 going to be? So the F of 7 is going to be 2 times 7 plus 1, which is 15. Okay, so that was pretty good. It seems to me like students are understanding the idea of this quite well. Now, I want to, actually, let me rub this out now, but that looked great. Guys and girls, I want to say that that was fantastic. So I think you've all understood that. So if the last lesson was about finding X and Y intercepts, I want to talk a little bit about different types of functions. So another type of function that we come across is something called a parabola. And a typical parabola has, the thing it has to have is something like that. It has to have an X squared in it. And so, if this is a straight line, because it only has powers of 1 for the X and Y, here the X has a power of 2. And so we call this a parabola, and the equation itself is called the quadratic equation, whereas this is called a straight line. Now, I want to try out this idea again. If I, instead of calling this y equals 2x squared plus 3, I instead call it g of x equals 2x squared plus 3. That is still a parabola, which is all good. And I want to try this thing again. I want to know what the g of minus 2 is, the g of 3, and the g of 7 is. And we'll call it again ABC. So using this function that I've given you here called the parabola, I want you to see, can you apply the f of x or g of x notation? What? 9, 18, 20, 1. And then for this one, that's 49, 98, and 101. Okay, cool. So as we go forward today, we are going to talk a bit more about parabolas. And for a parabola, the main thing we're looking out for is some x squared type of thing. Then we know it's a parabola. There are 2 other functions which in this 8-lesson series we will cover, but I'm going to leave them as a bit of a surprise for now. But yeah, so let's just do a quick little check-in. Thumbs up if you're feeling good, thumbs down if you're feeling a bit confused. Seems like you guys understand how this f of x, g of x notation works. Okay. Well, let's play a fun little game called Identify the Function. So I've given you some algebra about functions, but we all know that at some point we have to draw the graphs. And so here are 6 different types of graphs. And I would love some students to help me identify the different types of graphs. So who feels like they know one of the graphs? Pop your hand up if you feel like you could identify one of the graphs and help us with that. So can we have Boma? Can we unmute Boma? And then we'll go see what one Boma feels like she or he knows.
Hi, sir.
Hey, which one do you feel like you know?
I think it's B and C.
Okay, tell me what you think B is.
B is a parabola
B is a parabola. Yep. And what is
and
C?
C is a straight line.
Yep,
And
I agree with you.
I think it's an exponential, but I'm not sure.
Okay, we'll leave the other ones for now. What strikes you about B in the parabola? It looks a bit like a happy face, eh? If you think about it, like it looks kind of like a smiley face. If I put like two eyes there. So that's something I want to bring into play, is that parabolas look a little bit like faces. Thank you, Boma, that was great. Can we go to Kuchotso next and see if Kuchotso has some ideas about which one is which?
Sam, I think number C it's also a parabola.
Number, which one?
C, D, I mean.
D. I agree with
D
you.
with the concave down.
Yeah. So you're right. So it's got, well, I think of this as an unhappy parabola. So I call there's different ways of describing it, but it looks to me like an unhappy parabola, and that one looks like a happy parabola. So far, I agree with you, so well done. We've got 3 of them so far. Who would
number
like?
A.
Yeah. What's that going to be?
A and D is going to be a hyperbola.
Okay, so A is a hyperbola, and I'm gonna let someone else help us with the other ones, but thank you so much. That was fantastic. Let's go to Bianca.
Hi, sir.
Hey, which ones do you think you know?
E and F.
Okay, tell me what E is.
So E is a hyperbola, but it's a positive hyperbola, and then F is an exponential.
Yes. Okay, you even bringing in, this is fantastic. So when we talk about hyperbola, Bianca is saying that this is a positive hyperbola, and that's because the hyperbola is in quadrants 1 and 3, or essentially it's, they've been shifted, whereas this is a negative hyperbola. But again, we don't have to do this today. I'm just mentioning it because this is in quadrants 2 and 4. But we've got a whole 2-lesson series on that. So I don't want to get distracted. The main focus today is on these parabolas. Now, later, thank you, Bianca, that was fantastic. Later in the lesson, one of the things we have to know how to do to draw these parabolas is find the X and Y intercepts. And so we need to spend some time making sure we know how to find the X and Y intercepts. But that was great. And we will talk more about this graph. This is called an exponential graph, and it looks like it's taking off. It's like it's just taking off like that. And we'll talk more about them later. And then the hyperbola, I think of it as something with like a split personality. It's like it's got pieces and it splits into pieces. Okay, cool. Then let's talk about the simplest parabola of them all. If I had to think about the simplest parabola of them all, I think of the graph y equals x squared, or I think about the graph y equals minus x squared. And just to show you the basic shape of y equals x squared looks like this. So it looks like a happy face. And if I look at y equals minus x squared, it just looks like an unhappy face. So that's not too interesting at this stage. I would like someone to tell me what's the x-intercept and the y-intercept for the red graph, and what is the x-intercept and the y-intercept for the green graph? Any ideas? Have I lost my... Can't see. Kuchotso, what do you think? Let me unmute Kuchotso.
The x and the y intercept of the first graph is 0 and 0.
Yeah.
And even the second one is still 0 and 0.
Okay, really, really important. So this is a bit of a boring graph because the intercepts you can almost see it straight away. Is there anything else that you notice about this graph? Like, is it symmetrical in any way? The red graph or the blue or the green graph?
Yeah, I can see that is symmetrical
Yeah, so it's symmetrical.
on the point 0.
Yeah. So it's almost like if you put a yellow line through here and you could fold it across that line and it would look the same. So parabolas are symmetrical. That's important too. Is there anything else that you notice about parabolas? I'm trying to think that's important. I guess we could call this the turning point because it feels like the graph turns and it's curvy. Yeah. Awesome. Thank you, Kugoto. Okay, now I want to talk about making this first graph a little bit more exciting. I'm going to shift this graph in some way. I'm going to shift it down. And so if I shift this graph downwards, let's say I make it x squared minus 3. If this graph is shifted down, it's now going to look a little bit, well, I didn't draw that perfectly to scale, but it's going to look something like that. Now, using what you learned in the last lesson, I want you to find me the y-intercept and the x-intercepts of this green graph over here. I'll even call it, I'll call it f of x. Or in fact, let me call it g of x rather. So find me the x-intercept and the y-intercept of this green graph over here, using what you learned in the last lesson. And then someone who knows how to do that, you can tell me as soon as you figure that out. Okay, so y-intercept is quite easy because you can sort of see it, hey? You just have to make x 0. X-intercept is a little bit harder. What do we have to do for that one? So everyone is telling me they know that this is minus 3. Yes, Lolita. Let's see, Basichle. Now, what about the x-intercepts? How do we find those? I feel like someone told me earlier to find the x-intercepts, you need to make y equal to 0. So then I should do that. Lutando said the square root of 3. So, well, I could move the 3 to the other side and I get x squared. You're right. And when you square root, so now you have to square root both of these, you get the plus and minus root of 3. And so, in fact, let me put it on the next line. So the plus minus the square root of 3 is going to be equal to x. And so that means this one over here is going to be minus root 3, and this one over here is going to be plus root 3. You can also write this in decimal if you like. In decimal, I guess it would be like 1,5 or 1,6. But the same rules that we used to find x and y intercepts with straight lines, we can still use for parabolas. And the type of change, the transformation, this is called a vertical shift. And the reason it's called a vertical shift is that I have shifted the whole graph down. Now, does anybody know if instead of shifting the graph down, I want to shift the graph sideways? Does anybody know about shifting graphs sideways? So maybe instead of this graph has been shifted down, and I think we've all understood how to find the intercepts, how would I horizontally shift, let's say, the original graph? So the original graph, we'll call it f of x, and I want to shift this graph horizontally. Amakle, come online and tell me how you think we should shift the original graph f in order to change its position horizontally.
Hi, sir.
Hey,
How are you?
very good. And you?
Sir, I think that you would say,
Yeah.
for example, you would say g of x is equal to 2 squared minus 3, like for example.
Okay. So I think the 2 squared minus 3, the 2 actually makes the graph steeper. So this 2 in front, you're right, it almost like it forces the arms to go up more narrowly, but it wouldn't shift the graph horizontally. But you're right, it is a transformation. It just makes the graph narrower. Have you ever seen this idea? So let's say I take x squared and I go, I say x plus 2. Has your teacher ever done that? I don't know if you can still hear me there, Martin. So
No.
not, okay. Well, let's do it together now. So this is a new parabola. I've called it h, and all I've done is I've referred to the original, and I've made it x plus 2 squared. Now, I want us to try and find the x and y intercepts for this x plus 2 squared. So what I want to do is, are there any ideas about how we can find the x and y intercept for this graph that I'm saying that this is a horizontal shift of the original graph? It's quite hard to see it written like when it's written like this. So what we could do is we could write it like that and then multiply it out. So we could get standard form. Yes, Melly. Yes, yes, yes. So we get oh, but actually, you know what? If we think about it, this is actually, we don't even have to multiply it out further, because I'm just thinking, shouldn't we just make the whole thing equal to 0? So shouldn't we just, if we want to find the y-intercept, or sorry, if we want to find the x-intercept, we just make y naught. And if we want to find, I'm thinking we can make our life even easier here. So for the y-intercept, we just have to make x naught. So we go y equals, and we put a naught where the x is. And so we get 2 squared, which is 4. And to find the x-intercept, well, that's going to be this one over here. So what is my x-intercept going to be? What's my x-intercept going to be for this shifted graph? Yeah, it's going to be -2, because that's what's going to make this. So my x-intercept is just going to be -2. So let's just quickly look and see what this graph would look like. So the original graph was y equals x squared. And when I moved, when I've made it +2, when I made it +2 here, we found that the new x-intercept was -2. And then the new y-intercept was up here and was a 4. I know that's not a perfect drawing, but this is just a little bit interesting. The fact that we can shift this graph. When we made it a +2, it shifted 2 units to the left. So this means parabolas can get a bit interesting, because they can shift downwards, but they can also shift sideways, which is, we're going to use that later today. So Annie said, so can you please repeat how we solve for the x-intercept? So if you want to find the x-intercept, Annie, you just make y equal to 0. So what I did was, for this function h of x, x plus 2 squared is the same as x plus 2 times x plus 2. And what I realized is, if I multiplied this out, it wasn't going to get me closer to my answer. All I needed to do was make this thing equal to 0. And then I could see, oh, it's a quadratic equation that's been factorized, and x must be -2. The answer must be -2. So I hope that helps you. But just so we check something out, before we have a break, the last thing I want you to do is I want you to multiply out. So h of x, when I gave it to you, was x plus 2 squared, which we can write as this. But I want you to multiply all of these out, and I want you to write it for me in standard form. And the standard form of a parabola, which we'll get to later, looks like that. So Melly, we're going to get to the turning point formula in the next lesson. So for now, we're just building our basics, but you're on the right track. Okay, so last thing before we have our break, I want you to multiply this out. And this is just for fun, just to make sure we have a broad knowledge. And I want to know what this equals to. But Melly, I agree, it would be easier. Yeah, Amakle, let's go to you. What is your answer?
So my answer was x squared plus 4x plus 4.
I agree. So when you multiply all those out, you're going to end up getting x squared plus 4x plus 4. Now, that's fantastic. Now, the reason I wanted to show you guys this is it's important that you realize parabolas come in different forms. And so just like this parabola, this is a parabola, it has a power of 2. This is exactly the same parabola. It's just written in a slightly different way. And it's important that we know how to transition between the different ways of writing a parabola. And that's what I'll talk about in the next lesson. But I just want to ask for a thumbs up if you understand how these two are the same thing. Give me a thumbs up. And if you don't, give me a thumbs down. Okay. Awesome, awesome, awesome. Okay, so in this first half of the lesson, we learned how to identify different functions. We learned a bit more about parabolas. We learned how to find their x and y intercepts. And we also looked at how parabolas can look a bit different at times. So what I want to do now is I want everyone to stand up and turn their cameras on. And Asifisi, I'll come to you in a moment. I just want to quickly make sure we get our rest or we get a moment to just stand up and unwind. So everyone, please turn on your cameras if you haven't done so already. I know that sometimes you must feel like, oh, this silly man, why is he making me stand up and I'm cold? But I really believe that taking this break helps us retain stuff and it helps us learn better. And it teaches you a good habit. Like if you're going to study, you can't just study for hours and hours without taking breaks. It's just not a good strategy. Okay, so that's why I force you guys to do this for those who feel less than enthusiastic about it. Okay, let's start by just unwinding, literally. Just swing your arms or do something to just relax your body. Maybe you want to shake it out. Maybe you do drama. I always hear these drama students doing elaborate warm-ups in the classroom next door to me. And do whatever it does relaxes you. Maybe roll your shoulders a bit. Take some nice deep breaths. And just kind of, if you can, let your brain escape for a second. Okay. I don't know why I like this one so much, but I feel free. Okay, and then I'm a big fan of the tricep stretch. So you can do something else if you think that is more your cup of tea. But I like to do this. I feel my tummy muscles and my triceps getting a little bit of a stretch out. And then let's do the other side. Oh, and I can feel my humanity coming back into my body. How fantastic is that? Okay, and now what we need to do, I think, is we need to do some high heart rate activity. And today we're going to do skipping, virtual skipping or air skipping or whatever you want to call it. And we're going to do 20 skips. So you've got your skipping rope, pretending at least. And we're going to start in 3, 2, 1. 3, 4, 5, 6, 7, 12, 13, 16, 17, 18, 19, 20. And that is your mini workout for today. And let's just have our little brain break. So when I was a kid, these turtles were the rage. I don't know if you know who they are, but anyway, tell me what a turtle plus another turtle plus a piece of pizza is going to be equal to. Oh, wait, there we go. Bonus points if you know the names of the turtles. Raphael the Ninja Turtle, that's the red one. Well done. That's pretty good, Avile. Mike, that's the other one, Michelangelo. Yes, well done. Okay, so he has to be 22. So that has to be 22, which means a pizza slice has to be 2. And then I think if the pizza slice is 2, then this Raphael guy has to be 0. Which means, what is my final answer going to be? Mbali, Mbasa, I seem to have an answer. 22 plus, and this, yeah. So the final answer is going to be 24. Well done, in this one.
Good work, guys.
Yeah, a little bit of retro throwback Wednesdays. Okay, cool. Let us return to the work we were doing on parabolas. And Asipise, you had a question. So can we unmute you and then we can go from there?
Sir?
Hi, can you hear me?
Yes, I can hear you.
Very good, and you?
Sir, can you please explain this work that we did just now? Because I came while you were explaining, so I do not
Aha.
understand what's.
Okay, I'll tell you what, I'm going to do an example now for everyone, and a lot of the ideas are going to be applied from earlier, and then you can go with that from there. One of the things we did was we identified graphs. What type of graph do you think this is? Just out of curiosity, would you be able to name it?
A parabola.
Perfect, exactly. And what I'm going to ask students to do now is to find the x-intercept and the y-intercept of this parabola. So would you feel comfortable doing that? Or do you know, what is the approach we normally use when we find the x and y-intercepts for any function for that matter?
For x and y intercept, when we calculate y, we need to make x 0.
Okay.
And when we calculate x intercept, we make y 0.
Perfect. So if I had to ask you what is the y-intercept of this function called h, what would you say it is? If you were just looking at the graph quickly.
The y-intercept would be 9, sir.
Perfect. Okay, now you're definitely up to date. So I'm going to let you try and find the x-intercept of this function h together with all the other students. I want everyone to find me the x-intercepts for this parabola. Okay. And then just put your hand up again if you have another question. But I think for now you sound great in terms of this. So Artie, how did I get -2 for the x-intercept? You're referring to the previous question. The reason I got -2 was I had this going on. And what I did, Artie, was I said, look, to find the x-intercept, I need to make y 0. And so all that happened was I could see that the only way I would get 0 was if this x here was a -2. And so that's why the answer had to be x is -2. So that's what I was doing in the previous question. Now, for this one, I'm going to have to do this. And some of you may want to use what's called the quadratic formula. So, because this is a trinomial or quadratic equation, so some of you may want to use this formula where A is 1 and B is -6 and C is 9. Or some of you may see that you can factorize it into 2 brackets and see the answer straight away. I don't mind which way you do it, as long as you get me some x-intercepts for this parabola. So there should be 2x. Oh, well, there maybe won't be, because it depends on how if delta, how we're. Oh, I see. This is going to be x minus 3, and this is going to be x minus 3. No, it's, yeah. So your answers, your x-intercepts, there's actually only one x-intercept. Aha. And that x-intercept is going to be the 0.30. So this is an interesting graph. This graph, this is a lot like the previous one we did. So let me explain why it's a lot like the previous one. So in this particular graph that we've just done, it can actually be rewritten as x minus 3 squared. So this graph up here, this h of x1 and this one over here are the same graph. And so the reason there's only one x-intercept, maybe you can guess, what do you think the -3 does to this graph? The basic x squared graph goes straight up. This one is shifted across so that it cuts the x-axis only at 3. So it cuts that at 3, and then over here it cuts it at 9. So what we did, for those who are feeling confused, is we said 0 equals this thing. And if you use the formula, you would get the answer that x equals 3, because delta would be 0. If you factorized it, you get that this is x minus 3, which means that the answer, the x-intercept has to be x is 3. And all that's happened is this graph is the same as that graph. And it's just a basic x squared graph. Let me use a different color. This is just a basic x squared graph, but the x squared graph has been shifted across by 3 units. So you'll notice there's a -3 here, and with the horizontal shift, it shifts to the opposite way. Okay. So that was interesting because it had a little bit of the last one in it. And while I'm going to leave that one up on the board, because I think some of you want to ask questions, but while I'm answering questions, I'd like the rest of us who are feeling comfortable to find me the x and y intercept of this parabola. Okay. Pabalo, let's go to your question. What is your question?
Hello, sir.
Okay.
Said for me to refer to the previous question, there is another way to solve for the y-intercept. So there's this specific calculator that we use at school. You can actually solve. It's actually used to solve for the x-intercept and y-intercept. So in order to do that, we can say 0. Alpha equals 2, and then we can say x squared minus 6x plus 9, and then we press shift and solve, and then we press 0. That will give us, that will lead us straight to the answer.
Did you get x?
So there is another way.
Okay. Now, one of the things, you're right, there are some calculators that are like that. The one thing though is there's some questions where they force you to show your working. And so it's nice to be able to check your answer, but sometimes the way the question is set, there are marks allocated for more than just the answer. And so I just want to make sure that you do know how to do the methods because otherwise it might just be to your disadvantage. But it's nice to know, and it's nice to check. Absolutely.
Oh, okay. Thank you, sir.
Cool. While we're working on K, Kuchotso has another question. Kuchotso, what's your question?
So you see the example that you just gave us today, the one that we are doing right now.
Yeah.
There's a coincidence that they gave me the same question as a homework, but the difference is that it's not the -3, it's +3.
Aha.
So you will be helping me with my homework indirectly.
I aim to please. I aim to please. Okay, well, here's the thing, right? A -3 or +3 makes a big difference. So even though it looks similar, it actually can make a big difference. But what I would say is that the y-intercept has to be -3. And the reason is the moment you see, when you find the y-intercept, you always make x naught. And so that knocks that out. So your y-intercept is going to be, in this question, 0 -3. But to find the x-intercept of this parabola, you're going to have to go like this. And I don't want to give away the answer to that yet, but I want students to solve it. The two choices you have is to use the quadratic formula, which I think a lot of students would benefit from, or you can try and factorize. But I think most of you are going to say A is -1, B is 2, and C is -3. And then see if you can get me my two x-intercepts there. Don't worry, Annie, you can look at the recording and you can catch up with us. What do we think our answers are going to be for the x-intercept for these? So I guess I would write it. Who feels like they have the correct answer for this one? Pop it in the chat, or you can put your hand up and you can tell me. I don't mind. Did you get a negative delta here? Maybe there aren't any answers for this one. Did I go? Let's say b squared 4 minus 4 times a times c. I feel like there may not be this. There may be no answers to this one unless I've gone wonky here. Because b squared, so 4 minus 4 times -1 times c, that is going to be +4. That's -12. I get 4 minus 12. Oh, I've chosen I've chosen one of the ones that doesn't seem to have any roots. So tell me if you agree. Maybe I'm making a silly mistake, but I see inside the square root, I get -8. Okay, this is wonderful. Okay, let me explain what this means. So what does it mean? Yeah, no, that's fine. That's everyone, that is completely reasonable. So what does it mean if I'm drawing a parabola and it doesn't have any x cuts? It doesn't cut the x. It's got a y-intercept, but it doesn't have an x-intercept. Now, the reason you'll know this is delta is less than 0 in your quadratic formula, and we say the roots are non-real. But just to show you, is this graph K, is it unhappy or is it a happy parabola? just to start with? Happy or unhappy based on what you see at the moment? Suppose you can't really, most of you won't know. Now, we'll talk about this more in the next lesson, but if there's a negative in front of the x squared, it's unhappy. So the type of situation they're talking about here is some parabolas don't ever get up to the x-axis. So if I was guessing, I don't know an accurate graph, but if I was drawing this graph, I've only got a y-intercept at -3. It doesn't ever cut the x-axis. And that's when, if I try to find x-intercepts, and there are none, this is kind of what the graph will roughly look like. Give me a thumbs up if you understand why it makes sense that there's no x-intercepts for this parabola. Does that make sense to you guys? Like, it's like the math isn't lying to us. It's saying there are no x-intercepts because there are some parabolas that do not cross the x-axis. Okay, let's squeeze in one more for today. But that was good. We did the different scenarios. So sometimes, instead of writing parabolas in what we call standard form, we write them in the turning point form or the alternate form of a parabola, which is what we've got here. All I want to do to finish today is I want you to find me the y-intercept of this parabola, and I want you to find me the x-intercept. And we're doing this one over here. Now, notice how it's written. It's almost like, I don't know, I'll leave it to you guys. Give it a go, and then I'll give you feedback in a moment. Find me the x and y intercept of this parabola. Yeah, Kokotso, let's go to you.
Sorry, say it was a mistake.
Oh, it was a mistake. Oh, you mean with the previous one?
No, I mean, I pressed the resend button by mistake. I just wanted to go to the chat.
No problem.
The y-intercept is -3.
Okay. Oh, you've already got your answer. Okay, before I get there, if I want to find the y-intercept, I normally make x naught. So let me see if I agree with you. So I'm going to make x naught. And then I go -7. But now I have to be careful because there's a couple of tricks here in this one. But I think I'm agree with you. So naught -2 squared is going to be equal to 4 -7. And then I'm going to get -3. So for this graph, the y-intercept is going to be naught -3. Now, what's the x-intercept going to be? I'm going to have to make, you guys are going to have to solve this one for me. Well done, Kotso. There's actually two ways you could do this last bit, but I think most of you are probably going to multiply this out. Which is fine. What is my x-intercept? So notice what I did. I actually multiplied. I multiplied out. There shouldn't be a squared there. I multiplied all these out. So that gives me this. And then I had the -7 there already. So if I was using the formula for this, A is 1, B is -4, C is -3, and I get minus B, so it's going to be -4 plus minus. So B squared is 16. And this is going to be over 2 times 1. And so X should be 4 plus minus the square root of 28 over 2, which is going to be a little bit messy, but it will work. Who else can give me an answer for this? Yes, Kokotso, let's go back to you.
Sir, the way you're calculating is incorrect.
Ah, where do you disagree with me?
Yeah, the B is not 4, it's -4.
Aha, I agree. But here's the thing. When I go -4 squared, would you agree with me that -4 squared is 16? So it's a good
Yep.
point. But I get away with, well, I didn't get away with it, but I knew that when I squared -4, I get 16.
Okay, I think it got me over there.
Perfect. Okay, as a decimal, what do you guys get for your x-intercepts? I mean, when you calculate, I see Zander said 2 plus square root 11, 2 minus, so 2 plus square root 11, or x is 2 minus square root 11 is what Zander is saying. Do you agree with Zander's thing, or do you have a decimal one that you got? Anybody else have an answer? And then I can just grab my calculator quickly. What do you get when you go 4 plus square root 28 over 2? Are you getting the same? That's what I want to check. 2 plus square root 7 and 2 minus square root 7. Okay, so we have some different answers. Let me just make sure that I check which one I think it is. Let's have a look. Where is my calculator? Oh, my calculator is nowhere to be seen. So let's just put it into decimal just so we can compare. So Siposicle says 4.65. What is your other one, Siposicle? Okay, so Tigamatsu says 2 plus square root 7, 2 minus square root 7. That's fine. Can we put it into decimals just so we can see? So 4.65 is the one answer. What's the other one? Okay, so definitely one is 4.65, and the other one is x is equal to, now is it minus 4.65? I think that's the what we should be getting, because yes, it's minus 0.65. And that is the x-intercepts. Okay, everyone, we did really well tonight.